Welcome to 1.4. We just got through going through the shifting reflecting graphs, the notes on this page. Never has there been a more important set of notes as far as one note really having one set of notes having huge emphasis on the entire semester. And likewise, easily my favorite problems in the book, the ones that I most want you to master. And we can make these more challenging right now, but this is a good introduction to these. 19 and 20. We'll go through 20. So we've got graphing space down below. We've got a function, and here's how I'm interpreting this function. This is a factory that turns -2's into 4's, 0's into 3's. 1 day gets turned into 0 inches, and 3 days gets turned into -1 inch. And we connect the dots. So there are other points along here, but we're going to specialize in these points right here. So on the note page, we talked about pre-function and post function. This -1 is a post function. It happens after we find f of x. This +2 is a pre-function. Therefore, it's going to affect our right-left. It's going to affect our time. This -1 is going to affect our height. Pre-function, it changes x, it changes time. This is going to be a right or left. Here we have a pre-function, x minus 2, that's going to affect right or left. And then a post function we multiply by -1. We're multiplying the height by -1. So what used to be up 4 would now be down 4. Here's a pre-function. We're multiplying the values to the right by -1, which makes them move to the left. We're multiplying any values to the left by -1, which makes them move to the right backwards. Post function, half as tall. Pre-function multiplier, these ones are sneaky. We'll really specialize in that one when we get to it. So let's take a look what's happening here. We are just supposed to redraw these, and I will do that. We got A. I see f of x minus 1. I'm saying post function that affects up, down, down 1. Every point is just down 1. So -2, 4, which was right here, becomes -2, 3. 0, 3, I put in 0, I still get 3, but then I subtract 1, I get 2. 1, 0, which was right here, is now down 1. And 3, -1 is now down 1. Connect the dots. Okay, now the knee-jerk mistake is not, people will recognize this as a pre-function. Most will recognize this. I get very few that will take this and say, well, let's move it up 2, because this -1 we moved down 1, this +2 we must move up 2. That's not the mistake. The mistake is, do we move it right or left? And I'll ask people that. Is this to the right or the left? And they'll say, I don't remember. And therein lies the problem. This is not to remember. This is a 2-day head start. Everything happens 2 days sooner. If we had a 2-day start on a walk that used to take 10 days to happen, a trip that used to take 10 days, and we had a 2-day head start, it would only take 8 days. This is 2 to the left, or the MIVOX is -2, 2-day head start. So what was at -2, 4 happens 2 days sooner, -4, 4. What was at 0, 3 happens 2 days sooner, -2, 3. What was at 1, 0, 2 days sooner, and what was at 3, -1, 2 days sooner. Now, if that is confusing to you, please go back, take a look at this video again. And if it's still confusing to you, the burden falls on you now. You contact me, and we're going to get that straightened out. It's too critical for us. Okay, so pre-function. This is affecting the right-left. That I'm not subtracting 1 from f, I'm subtracting 1 from x. That is a 1-day delay If my corn is delayed 1 day, what normally would happen on day 5 now happens on day 6. This is 1 to the right. Post function down 1. Pre-function left 2. Pre-function right 1. Every point's to the right 1. What was at negative 2, 4 is now to the right 1. Negative 1, 4. What was at 0, 3 to the right 1, 1, 3. What was at 1, 0 to the right 1, and 3, negative 1 to the right 1. Connect the dots, and you can bet in quiz, test form, you're gonna be dealing with this type of thinking the rest of this semester. Okay, D. Okay, I'm getting this pre-function. 2-day delay, what normally happens on day 3 now would not happen until day 5. That's 2 to the right. And then post function is the height. I'm multiplying the height by negative 1. So what was up is now down. What was down is now up. That is upside down. And in our assignment, that's what I'm just going to have you do. Look at things like this and say, oh, it's 2 to the right, upside down, and that's it. So I'm going to do that with each point. I'm going to actually start with the 3, negative 1. I'll explain that. Hopefully I remember to explain that. 3, negative 1. 2 to the right, 1, 2, upside down, what was down 1 becomes up 1. There's 3, negative 1. The next point, 1, 0. 1, 0 is here. We're going to go, as you can see up above, 1, 0 is here, 2 to the right, 1, 2, upside down, but upside down 0 is still 0. Then we have 0, 3. 0, 3, 2 to the right, 1, 2, upside down, what is up 3 becomes down 3. And our final point, negative 2, 4. Negative 2, 4, 2 to the right, 1, 2, upside down 4 becomes negative 4. 2 to the right, upside down. Okay, I'm going to take a moment here and fold this paper just so we can get back up and see what our base function is. Here we go. That'll work. And we're now on E. We have negative 1 times x. Negative 1 is being multiplied by our right-left. So if x is a right value, it becomes a left value. If x is a left value, it becomes a right value. If x is negative 2, it becomes positive 2. But y doesn't change. So we're just multiplying the x values by negative 1. So we get in E, negative 2, 4. If I multiply the x value by negative 1, that becomes positive 2, 4. 0, whoops, is that too high? 1, 2, 3, 4. Yep, sure is. 0, 3, if I multiply the x value or make this backwards, this one is backwards. Backwards, it stays right here. What was to the left 0 becomes to the right 0. 1, 0, what was to the right 1 becomes to the left 1. And 3, negative 1, what was to the right 3 becomes 3 to the left. Okay. So here's the story right here. If I was to make this a multiple choice and you had to explain what effect this 1/2 does on it, here would be the 4 choices that I would give to you. Twice as tall, half as tall, twice as wide, half as wide. And you would have to come up with that. And I hope you would get that pretty quickly. I'm not multiplying half by x, I'm multiplying half by f of x, or half times y. I'm multiplying the y values by a half. Oh, so what was up 4 is now up 2. What was up 3 is now up 1.5. What was up 0 is still 0. What was down 1 is only down a half. This is half as tall. So what was negative 2, 4, the x isn't affected. the y is getting multiplied by half. What was 0, 3, the y is getting multiplied by half. What was 1, 0, the y, 0 is multiplied by 1/2, doesn't change. And what was 3, negative 1, the y gets multiplied by 1/2, and we get this kind of smashed down, half as tall graph. Okay, overwhelmingly, it's not even close. The pre-function multipliers cause the most problem. I mean, they didn't have an example quite like that, but I probably should take a moment and talk about that. Let's say we had a function, it's not this one, let's say we had a function that produced this point right here, and that's, I don't know what I'm doing there. That's all it did. This factory turns 4s into 2s. So I want to find f of 2x, but all I know is that, hey, this factory, all I know what happens is I have to put in a 4. So I need 2 times x to be 4. That's x equals 2. So if I put 2 into this factory, it becomes f of 4. Oh, f of 4 is 2. So f of 2x is f of 4. F of 4 is 2. F of 2x is 2. Oh, so what used to happen here happens there. Most people that make a mistake on this whole section make a mistake right there, and they say, oh, well, it's 2 times x, so the x's must be twice as wide. No, the x's are twice as fast. The x's are half as wide. And you might want to think of this as that twice as fast. 2 times as fast, x is time. What normally takes 8 days to happen now happens in 4. What normally takes 1 day to happen now happens in half a day. This is half as wide, which is the same thing as twice as fast. It's not even close. Most mistakes that are made on this are made there. So half as wide. What was 2 to the left up 4, if it's half as wide, is now only 1 to the left up 4. What was half as wide as 0, 3 stays 0. Half of 0. Half of negative 2, negative 1. Half of 0, 0. Half of 1, 1/2, 0. Half of 3, 3 halves, and the y value is negative 1. So it's kind of that whole accordion effect. You squeeze in, stretch out. So this one, just as an alert to you, probably ought to think through this a little bit here, but I want to talk about it. People are going to take this, and even as I'm saying it right here, I will guarantee you, I wish I was wrong on this, but I will guarantee you when we have a quiz and we have a problem like this or this, I'm going to get people, a lot of people. Boy, I wish I was wrong, but history tells me I'm right on this, that we'll make this twice as wide. We'll make this half as wide. It's not. It's half as fast. If it normally takes me 6 days to do something and it's half as fast, it doesn't take 3 days to happen. That's twice as fast. It takes 12 days to happen. Half as fast, twice as wide. So I'll leave 19 for you. You should be checking solutions on all problems, but wow, if ever there was a section to make sure that you are on target, not just getting the right answers, but it's like you could teach this, it's this section right here. So go back through. Do not rush this assignment. Let's make certain that we are 100% on board. It will pay off all semester long, or it will just nick you all semester long. Thanks, and let me know how I can help.